In May of 2011, the committee proposed to the MCA Board of Directors that we should develop and publish an entirely new method of estimating piping systems. Because when you labor items in the LEM right now, for example, a fitting, I labor a T, that labor unit that I pull out of there includes material handling, it includes labor for 3 joints, it includes a little bit of testing, it includes all of those things. One of the challenges that we have as contractors as we start to really get into the information more and try to set goals with our field crews, and we try to break apart the labor into what we're doing in our fabrication shops versus what we're installing in the field, is how do I take that labor once I won a project, I've got an estimate, I've got all this takeoff based on the fitting method that we have now, which has pipe, valves, and fittings, and I want to know how much labor is going to be in my fab shop. How much should I break out and put in my fab shop? How much should I put in the field? Or I've got a scenario which happens a lot on tie-ins or on industrial jobs. I'm getting spools given to me. I didn't buy the spools. All I have to do is install them. Or I've been asked to bid a labor-only job and I'm just welding joints. How do I put a labor on that? And so as we debated it as a committee, what we wanted to do is be able to develop a second system or method of estimating that would be based on laboring joints. And so we've been working on that. The joint method consists of counting and laboring the number of joints in a system and adding the labor of the installation of items and assemblies based on, and your handout says the equivalent length. Just in the last 2 or 3 weeks we've changed that to be the weight of the item or the assembly. So strike through the equivalent length and put in weight. There are other estimating systems out there that are based on a joint method like this. They utilize an equivalent length. We've found in some of the work that we've been doing that there are inherent inaccuracies in using an equivalent length. The best example would be, for example, a flange. A flange is really short, so its equivalent length is really short, but it weighs a lot. And when you start to look at the labor that would be associated with just putting a flange in place, it would generate too small of a labor unit compared to, I think the comparison we were making was to a 90. Mm-hmm. And when you did the comparison of the two, it didn't make sense. So we had to go back and run some other calculations. This was a little controversial. We weren't sure if the MCA would support it, but the more we looked into it and talked to contractors, this is one area where we're getting questions all the time. How do I come up with labor for just a joint? How do I break out fab shop labor versus field installation labor? So we decided to make the proposal and was approved by the board, so we've been working on that. The joint method absolutely better supports the ability for contractors to identify labor associated with the components of fabrication and installation, even down to what a cut and bevel is going to take time-wise. So we've got an example here that we've been working on that I'm going to pull up. I'm going to let Ron take it from here. This happens to be a spool that we used as the example, and let's talk about this one, Ron.
So, you know, earlier when we were talking about back-to-back fittings, so whenever we put a T, 90 on a T or a flange on a T where we've got back-to-back fittings, this is where, using this joint method, we can accurately go through and count all of our joints, where before we were counting a T, it had 3 joints, 90 had 2 joints, and we were coming up with too many joints. So in what I'm calling the fitting method, the old method, that has a joint in for every side of the fitting or every opening of the fitting. So now whenever you go into the joint method and do it, you would actually be counting the joints. So like for instance, you know, around this T right here, so you got a T and you've got this flange welded right on it. What you'll do is you'll just go through and count your actual joints on this spool. Okay, so I would just march around the drawing and count all of my joints. So obviously, you know, field joints can be, or shop joints can be counted separate than the field. So I'd start there with my shop, just march right on around the drawing and count all of my field or my shop welds. And I would not take off or count my field welds yet, just continue counting all of my shop welds. This particular one has 15 shop welds on it, and it's got 3 field welds. So there would be a typical spool and how you'd go, you know, you just rip off your material, your flanges, your 90s, your pipe, all of your material items, and then once you get done, you go back and you count all of your joints. So it's just simple. Now, this is just an example. Okay, so here's just a bunch of items that we've taken off. And then I've done a comparison. This is the traditional method, the fitting method. Now the fitting method, you notice that there's some zeros down in here. That's because all of these items are included in these items up above. So take, for instance, the bolt up. The reason that there are no labor hours for the bolt up here is because we just said a few minutes ago that in the basic assumptions that the bolt up is included in the flange. So that 5.31 number, 5.31 hours, includes the bolt up. You know, the cut and bevel is also included in the flange or the welds that are on the 90s or whatever else you're taking off. So that's why when you're doing it the traditional method today, the fitting method, there are no labor hours for those items down there because they're included in the labor hours at the top, the items themselves. Now when you go and you do it the joint method, you'll notice that there's labor hours on everything. Now the nice thing about that is I can come down, and when I get down into the butt weld area, there was our 15 8-inch butt welds. There is the hours representing those butt welds. So for a total of 47, almost 47 hours. So of the 104 hours, I can definitively tell I've got in my shop, I should have at 1.0 MCA, 47 hours. So that's why on this side, on the joint method, everything has a labor unit on it. And then when you get down to near the bottom and you're actually doing the installation of those spools, you've got a labor hour per foot for the installation of the spool, and then there's the weld hours per weld. So you got 9.4 hours for that. Also notice that on the butt weld, we don't give any consideration as to whether it's done shop or field as far as factoring that number or putting the productivity factor on. That's what you need to do for your shop, right? You know what your productivity should be for the shop versus a field. But the point is, there is the difference. If I were to counting this in the joint method or taking it off in the joint method, I'd now come up with 104 labor hours as opposed to 123 labor hours before. Now what's the significance of this? There's 6 8-inch welds that I didn't need. Okay, because of the back-to-back fittings, there's 6 8-inch welds that I didn't need. If I were to increase those by those 6 welds, these two numbers are the same. And they should be, because we put those 6 welds back in, right? And then it's an exact comparison, apples to apples, of the way we do it today. So this new fitting method is going to be able to give you the ability that you're going to be, our joint method, you're going to be able to take those spool drawings, and if, like Tim said, you just had to go install a bunch of spools, just start ripping off the material for install spool, and you got a labor unit for it, you got a labor unit for your field welds, and notice also, everything gets a labor unit on. There's a bolt up. Now you know what a bolt up's worth. You didn't know that before, right? You didn't know what the bolt up, how many man hours were for the bolt up. So this breaks this thing down a whole lot easier. So now you can definitively say what goes in the shop and what goes in the field.
And what specific tasks are worth. So the timing on this, we have a committee meeting here in about 4 weeks. And we're hoping actually to be able to publish a lot of this information shortly after that. So the committee meeting will be reviewing some of this and checking it, and there are some things in here that we need to agree on as a committee in terms of how this was developed. But once the committee agrees on it, this will be pretty quickly published and available. If you look at the WebLEM now, at the very bottom folder says joint method, and if you click on that, it says currently under development or something like that. So this is the state that it's currently in. So we thought we would show this to you right now. You don't have copies of it because it's not been checked or published, but it should be enough to give you an idea of where we're headed. And we're glad to answer questions if you have any on this direction or anything related to the WebLEM.